So I hope the screen is visible to everyone. You are able to see the screen. Okay. Let me save the program as create or lock. So now let me immediately let me use the same scenario that we have used in the last session of the race condition, and ultimately it led it to the deadlock. So I guess this is the race condition that we solved with the wait and notify, and the synchronization made the only synchronization solve the race condition, of course. I have to open up the program for deadlock. Let me check this end. So rest D. Yeah, so this was a program, I guess. Yes, this is the program that we use to demonstrate the deadlock situation, right? So the thread 1 and thread 2 were locking the resource, and then they were waiting into the circular wait situation where thread 1 was waiting for the thread 2 to release R2, and thread 2 was waiting for R1 to release resource 1. So let me use the same code with a bit of modification. And what we are going to do is we are this the same program. So instead of thread D, I will call it as a lock because I'm going to use a different locking mechanism to lock the resources. So our entire setup is going to be entire setup will remain as it is. So right now we are using synchronized mechanism to lock the resource. Now we have to use a different mechanism called as a re-entrant lock, which is a kind of a monitor. Now in one of our session we said that we will understand what is the difference in a different thread locking or thread synchronization mechanisms that operating system has provided. So today we will see the kind of a monitor mechanism that we have with the name re-entrant lock. So let me create a re-entrant lock first. So for creating a re-entrant lock, I have to import a package java.util.concurrent. Okay, concurrent re-entrant lock. Now we are going to make use of this re-entrant lock. Sorry, one more thing. Java.util.concurrent.lock dot re-entrant lock. So this is the up to locks is the package, and from that we are going to make use of a re-entrant lock. So our entire setup is going to remain as it is. So now how the this re-entrant lock works is, let me explain the scenario with the paint. Let me open up the paint. Now what we have created up to this lecture is we have created two resources, right? So we have created two resources, and there are two threads which who are going to access this resource. So let's say this is the thread 1 and this is the thread 2, which is going to access this resource. And what we are doing is this resource will be locked. This resource will be locked by the thread. So the thread will capture the resource. This resource will be again captured by a thread, and this lock is exclusive with threads. This lock is exclusive with the threads. So now threads have their own locking mechanism and they can lock a resource with the synchronized keyword. So they do that, right? So instead of that, what we will do is we will create a resource. Now, to better understand what I'm really trying to say here is, so okay, there are resources, there are threads. So let me create a small lock diagram here. So this lock is the thread, right? So thread is owning this lock, and this thread 2 also have its own lock. So what these threads are doing is they are putting this lock on the resources, right? So these threads are putting their own lock on the resources, right? So what has happened is, let's say thread 2 locked resource 2 and thread 1 locked resource 1. So that is what had happened. And now they have one more lock available with them, which is not in use. These both threads have one empty or free lock. And what they want is they want to acquire the second resource which is available. But when you try to lock the second resources with your own lock, you find that some other thread, that is thread 2, has already used its own lock to lock the resource. And that is vice versa too. That thread 2 will try to put this new lock on the resource 1, and it will find that the resource 1 is been already been locked by the thread 1. So they have their own locks, two locks. Each thread have two locking mechanisms and they are using it. Now, what we can do is, instead of providing locks with the threads, like thread 1 have one lock and thread 2 have one lock, what we can do is we can create an independent lock. Let's say we have this lock and there is one more lock, let's say. So what we can do is, if either of three thread, let's say if you want to use this resource 1 and resource 2, if anybody wants to use resource 1 and resource 2, let's say we will call this lock as resource lock. So what we will say is, if you want to access this both resources, get a lock on resource lock. If either of these threads want to access this resource, then they must get lock on this external lock. And now this lock is not in the control of thread 1 or not in the control of thread 2. This is totally independent lock. So what we can do is, this both threads will compete for this external lock called as resource lock. And if say now there is only one lock called as resource lock. If thread 1 gets the lock, then it will use it. If thread 2 gets the lock, then it will use it. Neither, like both threads will never get the same lock at the same time. That is not possible, because as soon as one thread owns this lock, owns the key to open and close this lock, then thread 2's request will be hold or put on hold, and it will not be succeeding. Also, if say let's thread 2 gets the lock and its key, then thread 1 will be put on the wait condition and it will not get the lock. Are we clear with what we are trying to achieve? You will create an external lock which is not in the control of thread. Any doubt in the explanation? If you have any doubt, I will explain again. Am I audible? Okay. So shall we proceed with the program, or shall I repeat the concept one more time? So there is one request for repeating, so I'll repeat immediately. No problem. So present scenario, let me repeat. So we have thread 1, thread 2, like this. Now each of these thread have their own locks with them. So thread 1 have two locks with it, lock 1 and lock 2. And thread 2 also have its own lock with it, lock 1 and lock 2. Now these threads can go get this, can put this locks on the resource. So let's say we have resource 1 and we have resource 2. Now when thread 1 wants to put a lock, now let me use a different diagram. What will happen is, if you are locking the resource, let's say what happens when you lock a resource with the thread's own lock is, this is a bit expanded version of the same diagram. We are going to call it as T1. So this is a bit expanded version of T1. So what happens is, this resource 1 is available with the thread 1's own locking mechanism. So I will call it as resource 1. This is resource 1, and the lock has been put on the resource, right? Meantime, the same thing happens with the resource 2, like thread 2 is been expanded, and there is also a resource called as resource 2. So this is my second resource. Now thread 1 also have two locks with it. So what it does is it takes this resource and it puts it into a lock, right? So here we have resource 2, which is locked by thread 2. Now each of this thread still have one more lock available with them. Each of this thread still have one more lock available with them. And what they're trying to do is they're trying to log this. Now thread 1 tries to log this resource, and this is not going to happen. Why? Because this 2 has been already logged by T2. And the same thing will happen with resource 1, that thread 2 will try to lock it. But again, this is not going to happen. This lock will not succeed because thread 1 has locked it, right? Is the scenario clear right now? At least the first scenario, that what is the current situation? Okay. Now, as we have this two locking mechanism and each of the lock is owned by the independent thread, what is happening is the deadlock situation has appeared. Now, instead of that, what can be done? People, the first solution, let me use a completely new diagram for this, or we will keep this scenario as it is here for the reference, and I'll expand the parent more. Okay. Now the next scenario, new scenario, is something different. The new scenario is, we will say there are two resources. There are two resources, and then each of this resource is already been put inside a lock. Each of the source, the system has created a lock on these two resources. Now thread 1 and thread 2, we will say this is thread 1 and this is thread 2. If this either of this thread has to use these resources, then it must lock first, right? And now you can see that this lock is a single lock. So if one thread locks it, the second thread cannot lock it. Second thread cannot lock it. So now earlier the locks were with the threads and we were putting the resource into the lock of a thread. Now instead of that, what logic we will develop is we will not put the resource in the lock of a thread. We will create a lock which is totally independent of threads, and then if the thread wants to access the resource, then it must acquire the lock. If the thread fails to acquire the lock, then it can't use the resource. So let's say if thread 1 locks this resource, puts a lock on this resource, then the request from thread 2 will not get succeed and thread 2 will go into the wait state. Now as both resources are locked, thread 1 will complete its job, and as soon as the thread 1 releases the lock, thread 1 completes the job, and when it releases the lock, the thread 2 now can compete and get the lock and proceed. And now thread 2 will get succeed by putting the lock. Second scenario clear? What we are trying to achieve? Okay, great. So there are two replies. Anyone want me to repeat this again? No need to repeat, right? Great. So let's proceed with the program. Let's implement the program. Give me a minute. So let's start writing or developing the program for the same. So what we will do is, now as you can see that earlier the locking mechanism was implemented by each of the thread independently, right? So instead of that, we have to create a lock which is available for both threads T1 and T2. So the first change is going to come here. So this is the program that I borrowed from locking. So independent locking means the synchronized block is actually putting the lock. So this synchronized first block and this is synchronized second block. This is synchronized first block of T2, and this is the synchronized second block of T2. So if I look at the code, I really don't need the synchronized blocks because I want to put a lock on a lock. Lock will be a central resource. Lock will be a resource of the main program and not of the thread. So we don't need this independent lock. So I'm going to remove that, right? So let me delete this. Let me delete this also, and its closing bracket. Similarly, with the thread 1 also, we don't need this independent lock. So let me delete synchronized calls and their closing brackets. Now what we have done is we have done first modification on the program. Now neither of the thread have blocks, so the both threads are empty. Now they need to use resource and they need a common lock. If T1 gets the lock, then T2 must not get a lock. If T2 gets the lock, T1 must not get the lock. That is what we want to achieve. So let's create a common lock. For that, for creating a common lock, I'm going to make use of Re-Entrant lock class, which is inside util concurrent locks package. So let me initialize object of Re-Entrant lock. So I'll type Re-Entrant lock is equal to new Re-Entrant lock. So this will initiate our object of Re-Entrant locking mechanism. Now we have created a lock which is common. मॅम बोला की 3 वाजता आता मुजुमदार सरांनी फोन केला 3 वाजता बहुतेक आपल्याला बोलवतील जिओचं काय ते विचार Sorry for that short break. So we have created a lock which is common for the entire program. Now what we have to do is we have to pass this lock to the thread 1 and thread 2. See what our diagram is suggesting is this lock must be accessible to thread 1 and thread 2. In the same way, the resources are available to thread 1 and thread 2. How we have made these resources available to thread 1 and thread 2? We are passing these resources in the constructor of thread 1 and thread 2. In the same way, this common lock which is available at the system will pass it to the thread 1 and thread 2. So one modification, we will pass the object of this Re-Entrant lock to the thread 1 and thread 2. Right now, right now the thread 1 constructor do not have a provision to accept the object of Re-Entrant lock. So we'll modify the constructor of thread 1. So let's go and create here the resource called as Re-Entrant lock. Let me call it as lock, or let me call it as R lock. And now Re-Entrant lock, which has been passed by the main method, we have to get it into the R lock is equal to lock. But to be very specific, this dot Re-Entrant lock is equal to lock. The same modification is required in the constructor of thread 2. Let me do that. So again, Re-Entrant lock, R lock, and the object which is passed to the constructor will be captured here. So lock, and in the constructor we will say R lock is equal to lock. Any doubt in this up to this point? Is it clear that why I'm using this re-entrant lock object, why I'm passing it here? If you have a doubt, okay, clear. Great. Any other person have any doubt? No problem. Great. So this re-entrant is, I hope so it is clear for everyone. Now, next job. What the threads has to do is, as soon as they try to use this resource, the first thing expected by this thread is they have to put a lock on the resource. They have to put a lock on the resource. So let's write that code. So re-entrant the rlock dot lock, and as soon as your job is done, we'll write here rlock dot unlock. So when your program execution starts in the thread, the first thing it will try to do is it will try to acquire a lock. If it succeeds in acquiring lock, it will execute the code, else it will wait. As soon as its job is done, it will release the lock. So let's try the same thing. What we have modified thread 2. On the similar basis, we'll write the code inside thread 1. So let me write rlock is equal to lock. So you are putting a lock on the common resource, and then rlock dot unlock. So you are releasing the lock on the monitor. So let me save this and let me try to compile. So Java C, what is the name of the program? thrlock.java. Hopefully it will compile, yes. And Java thrlock. So thread 13 trying to get, now you can see that neither of the thread has been blocked. So 13 got the lock on R1. 13 says trying to get lock on R2. Then 13 says that got the lock on R1 and R2. So then 14 says got a lock on R2. Then 14 says trying to get a lock on R1. And then 14 got the lock on R1 and R2 and then finished. So now the deadlock is not going to appear. Now let's say if I just create an infinite loop here, let's say while true. Now, which is this thread? This thread is thread 1. Now if we create an infinite loop here in the thread 1, let's see what happens. Let me compile. Okay, unreachable to the code. So Java compiler is telling that it can't go below this. Maybe what we can do is we will not press enter. So so I'll make the thread sleep for, instead of now 1 second, I'll make the thread sleep for more than 5 seconds. I mean, let's put it as 6 seconds. Now thread is going to wait for sleep for 6 seconds. So it again depends who gets the lock first. We will hope that it will demonstrate what we are trying to achieve. So let me clear, let's say Java C thr lock dot java and Java thr lock. This has been okay. Now it is not going to come. After 6 seconds, it will come out of the wait state. So I hope you saw this, what has happened. So the thread got the lock and it goes into the sleep. As the one thread gets the lock, the second thread can't get the lock, right? So thread 13 finished it, and then thread 14 started its execution. Is any doubt in the execution? This is how the re-entrant lock will work. Any doubts? Okay, that question, no doubt here. Great. Now I have a question. Do you see the limitation of this approach? Can anyone tell me what is the limitation of this approach? You can put it in the chat window, or you can directly unmute yourself and ask me. Oh, sorry, tell me what is the limit. Thread 2 is ideal. Okay, no, thread 2 is fine. So thread 2 is ideal or while 1 is sleeping. Okay, that is a nice guess. Okay, Shardul. Nice catch. That thread 2 is idle, even if the thread 1 got the lock and did go into the wait state, but the sleep state, thread 1 is not doing anything. Yes, because why did this happen? Because thread 1 got the lock on locking mechanism. And how many locks we have? We have only one lock, right? So whoever gets the lock, parallel execution is not possible. Nikhil Jugai. See, the exact pinpoint answer by both of you. Answer by Nikhil Jugai is a bit relevant. That's what I wanted. So here I have only one lock, right? And using one lock, I am trying to lock both the resources. So let's say my system have 10 resources. The thread 1 needs the resource 1, thread 2 needs only resource 2, thread 3 needs only resource 3, thread 4 needs only resource 4, thread 5 needs only resource 5, and so on and so on. And but I have only one locking mechanism, and I'll be using the same locking mechanism to lock all the resources. So that is not good case. So it has been recommended that you should have enough locks to lock the resources independently. Is it clear what I'm saying? So whatever the both answers are correct. Aditya Kavi saying yes. Okay, Aditya got this. So we are seeing this concept called as a monitor, right? So you people have a monitor for a resource. So whenever we want to put a lock, we kind of monitor the resource, right? We kind of trying to monitor the resource. Now see what has happened here is parallel execution is not possible is the very correct answer. But before this even, I have one question. Let me run the program again. Let me run the program again and observe what is happening. So thread 1 goes into the sleep state. What happened? Thread 4 is not a thread 4 or that 14, whatever the number is. 14 is not getting a chance to execute, right? But what is happening with the 14? 14 is getting locked here. So unless and until 14 is not going to get the resource, 14 will not come out of it, right? So who is sleeping? Thread 1 is acquiring the lock and sleeping for 6 seconds. So let me make this time of 10 seconds, right? Now my thread 1 is going to get the lock and it will go into the sleep state for 10 seconds. So let me compile Java C, HR. Okay, lock Java C thr log dot Java. We compile Java thr log. Now for 10 seconds, system is not going to do anything, right? So system is totally idle. And then system wakes up and then executes the job. Now, now here I will bank with the answer given by Shardul. See, I said that both answers are correct, right? Pinpointed answers. Like Shardul's point is also correct and Nikhil's point is also correct. Both. So I got kind of a two answers which are getting applied here. So in the perspective of Shardul's answer, the thread 2 is sitting idle and doing nothing. Why it is doing nothing? Because it is waiting for a lock. And thread 1 is culprit who is locking the resource and going for a wait or a sleep of 10 seconds. So parallel things are not happening. So the best solution is to create two locks, each for each resource, and thread which is trying to lock a resource should get a lock on that particular resource, that particular lock. So let's say our lock is for resource 1, then we might have R1 lock for resource 2, and so on and so on. But is there a way that thread 2, instead of getting blocked, it will try to get it, and if it gets it, then it's good. If it doesn't get it, then it should do something else. So that is try lock, right? So what we can do is, if try lock, if this lock call returns a true value, that is the things are locked. If these things are locked, of course, before leaving the loop, you must say unlock. Else, what we will say is this dot get ID, sorry, this dot get ID, and so let's try to save this and then compile Java C thr lock.java. Okay, r dot try log, compiled Java thr lock. Now you can see that thread 14 says better luck next time. It is not getting locked. Parallel it has executed. And thread 1, which is the culprit, that is still waiting into its own loop and then executed. Did you see the difference? Did everyone observe the difference? What happened when we put a try lock? Yes, is the answer, Aditya. Anyone else have seen this? Okay. Did you see this? What happened? Aditya, Nikhil, when we change it to the try lock. Am I audible? Hello? Hello? Okay. So, not seen. Okay, guys, let me restore this. So I'll put a comment on if block and the code of else block into the thread 2. Thread 2 now simply will try to get a lock. Like here, I will write the code rlog dot lock. Now let's compile again. So count now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now thread 13 will wake up. As soon as the thread 13 wakes up, it will complete its job. Now thread 13 completed. Then thread 14 started. So 14th number thread, that is thread 2, it's simply waiting for thread 13 to finish. So this is not really a parallel execution. Thread 13 is blocked because of this call. That call is blocking that you must get a log before execution, and that is true. That 13th thread number 2 must lock this R lock before executing this code. But what if after unlock you have a job which has nothing to do with this? For example, system.out.println. Here we'll say what we are going to do is something, let's say, which is not related to anything. Job with resource 3, and this job has nothing to do with whether you get a lock or you don't get a lock, right? Whether you get a lock or don't get a lock, that it has nothing to do with. But the program thread 2 will keep on waiting till the moment the r lock is not released. So it is not a parallel execution. So what we can do is, instead of locking, we will use try lock. Now my thread 2 is saying try lock. If you get a lock, execute the code of locking. If you don't get a lock, go on proceed the else part. That is better luck next time in our case. Now, if I save this and compile, if I compile it, let's run it one more time. Now you can see that 14th number thread is not waiting at all. It is immediately saying that I'm not able to lock, so better luck next time, and then execute it. So the thread finished its job. 14th number thread is simply not dying. It is completing its else part, and now thread 13, it is waiting. Now let's wait for thread 13 to finish its job. So thread 13 will wake up after 10 seconds, and then it will finish its job and the program will terminate. I hope the 10 second time has elapsed. Why it is not waking up? Oh, have I increased the time? I increased the time to some amount. Have I put any other statement here? Yeah. Yeah, so after 10 seconds, now it is coming out of it. I guess both threads were suspended by the system, so that's why we didn't get the output in time. Now, if everyone have seen it, what is happening when we are using a try log, or still I show it again? Did you observe this? What things changed in the program? What is the effect of try log? Okay, fine, got it. Is the answer by Aditya. Does everyone got this concept? What is a try log? Okay, can somebody tell me what is the limitation of this now? What is the limitation of this? Now you tell me what is the limitation of this try log? What we are doing right now is. Can anyone put the limitation of try log? Thread 2 doesn't acquire a log. That is quite correct answer. So thread 2 didn't get a log and it completes it. So what if, let's say, let me improve the code a bit. So Shardul has hit again a quite relative answer. So let me modify the code. So instead of 10 seconds, let's say the thread 1 goes to sleep for only 3 seconds time period, right? So thread 1, instead of sleeping, having a sleep time of uh, 10 seconds, it is just sleeping for 3 seconds. Now let me recompile again and run. Okay, ja. So thread lock. So again, 14 says better, like next time. So even if for fractions of time, let me bring that out time for 1 second. Let me bring the waiting time of thread 1 for just to 1 second. Still the thread 14 is not doing its job. So thread 14 immediately going out of a race. So as soon as thread, what is happening is thread 14 is taking out the resource and it says that okay, the locking is not possible. So immediately it quits out of the race and come out of it. So that is not a good case. So what is the next provision here is in the brackets of try block, you can put a wait time. Now what I'll do is I'll put a wait time of 1500 milliseconds. So it is 1.5 seconds. So for next 1.5 seconds, it will wait. If it is not going to get a lock, it will wait now. If after 1.5 seconds, still if you don't get a lock, then you will execute else block. But after 1.5 seconds, the program will again check whether you are getting a lock or not. If you get a lock, very nice, the program will execute. So let's try this now. Okay, our try lock. I need to pass a time in milliseconds. So re-entrant log r dot log and r dot unlog. I need to create a object of milliseconds. if I say 1000 and ms millisecond, it is not able to locate the ms symbol. See, I have to, wait a second. I have to convert it to the time unit. Okay, I will get back to this. I have to convert this millisecond string into the time format. So what is next possible thing is we can uh, pass how much time you want to wait. I have to get back to this also. I was expecting that it will work with this 1000 only. Oh, method. Let's say found try r dot log 1000. Not a, so I have to pass a millisecond time unit, but I have to create an object of unit here first, and then I have to convert this string into the millisecond time period and then pass it. We'll see this later on, maybe in the next session. Before that, I have to see how to convert the uh, 1 second time into the millisecond time unit and then pass it. But that is also possible. Like instead of waiting, instead of what we can say, immediately it will it will try it, and if you are not getting a lock, immediately it will proceed with the else block. So instead of that, what you can do is you can pass 1000 here. So what will happen is 1000 plus I have to pass here time unit TU here, and that TU is an it will be a constant value. Let's say uh, it will be a millisecond or a second or hours. So either of this value will appear here. That how what this 1000 represents. So if you have this millisecond, then after 1 second, this try lock mechanism will again try to get a lock on R lock. If it succeeds after 1 second, then it will enter with this code. Else, it will execute the else part, right? So this TU unit part is remaining, that I will confirm for sure. We will see it, or I'll upload a separate video of this, how to convert into TU unit. Any doubts on this? Okay, in the suggestion box, somebody has put time unit may work. Let's put it by Nikhil Jugal and Siddhi Patel. Okay, fine. So I really right now I don't have what we can say. How should I convert it to the time unit? I thought that this will work. Actually, it used to work. I think this is a new thing that I have to pass a time unit also. But it works. Like if I put a value and then a unit, which I want right now is a millisecond unit, or maybe minute, or maybe a hour, whatever we want. After that much time unit, the code will execute. Fine. Now, very important part remaining from our threading discussion is, right, until this moment, I have covered only part of how to create a thread using thread class. Now, we have to also cover the part of creating thread using runnable interface. Like, what if your class have, what if you want to use some other class here? For example, if let's say you are saying extends JFrame, if your program is extending to JFrame, how you could extend to the thread class? That is not possible. So threading mechanism in Java performs this in both ways. Like it will execute. You can create a thread using thread class. Also, you can create a thread using runnable interface. Right. So let me show you how to create a thread using runnable interface. For that, let me use a new file and let me save the program. Let me call it as thri.java, threading interface.java. Let's create a class public I. and let me say implements runnable. So now, because of this runnable interface, whatever code we want to write, which has to run as in a thread, that again we can put into the run method. Lecture सोडून ना त्याला लागेल. Guys, I have to go for a meeting, emergency meeting. There is a call. We will see this runnable in a short, and we will explore it in detail. 2 मिनिटं देतो. हो ना, लेक्चर चालू आहे ना. ठीक आहे, मी 5 मिनिटं देतो. So, what does run method? Now, whatever we can do is whatever code that we want to run as in a thread, we can put it inside this void run method in the same way. So here, what we will do is, let me write a for loop which we want to execute as an for 10 minutes. I is equal to 0, I is less than 10, and I plus 1. Here, let me, let's say system.out. This is run method. Now, the same thing we will create with the main. Integer I is equal to 0, I is less than 10, I plus plus, and this is main method. Before starting the main method, we will create a thread. Now, see, I cannot create an object of thri obj is equal to new thri and say obj dot start. Now, this is not going to start a thread. Why? Because thri class is not extending the thread class. thri is not extending the thread class. The thri is implementing a runnable interface, because of which you are getting access to the run method. But who does have a start method? Start method is not with the runnable interface. Start method is not with the runnable interface. Start method is of the thread class. So how we can do this is, we will say thread t is equal to new thread, and here we will pass this obj. And now we will say t dot start. See, what we are doing is, we are creating object of our class, then we are creating object of thread class directly, and then t dot start has been written, and in what will happen, this t dot start will start running the run method. Why it will start running this run method is, we are passing the object of thri, and how come this finds the run method? Because thri is implementing a runnable interface. So we know that if we implement an interface, then it is compulsory for a class to provide the implementation of the methods that have been defined by the interface. So this run method is been, sorry, not defined, declared by the interface. So this run method is been declared by this runnable interface, right? Now if I compile and run this thri.java, okay, public, I have made a mistake, so it must be capital. Let me change it to the capital here also. Now Java C thri. Now you can see that the main method and the run method both have executed, right? Both threads are executed. What we can do is, to make sure that they are running in parallel, we can, after putting one output, we can make this thread sleep for some time. Thread dot sleep. Let's say it will sleep for 1 second. And see, now the main method and run method are executing in parallel. So here you had a main method, then run method started, then we have finished with the run method, and then the main method is again executing. So this is again creating a parallel program. So here my question is, how many run methods you can have per class, per class. How many run methods we can write inside one class? One. That is the correct answer, that we can have only one run method per class. So how many threads we can create inside a single class? Many. Neil, can you tell? Okay. How many threads we can create inside one class? Okay, great. Because we can create thr1, thr2. Okay. So we can create multiple threads, but how many run methods we can have is one, right? So all of these methods, all of these threads, not methods, all of these threads that will create multiple threads will execute same code. What if we want each thread to execute separate code? So what is the limitation in this approach still is, like I am able to create multiple threads of this class, but each of this thread is going to run the same code, which is provided by the run method. What if I want to create multiple threads inside this class, and each of this thread must execute a separate code? That is what we want. So how to do it? So let's see how to do it. What we can do is, let's say thread T1 is the thread that you want, thread T1, new runnable. So here many people get confused. See what we are passing to the thread, we are passing the object of THRI class. What THRI is doing is, it is saying implements runnable. So I am writing it in shortcut, implements runnable. THRI saying implements runnable. So instead of passing a THRI, which is implementing runnable, I am directly saying new runnable. Now, new runnable is an interface. That means this interface have a method called as public void run. So inside this new runnable, let's directly write public void run method. So let me say public void run, and here write the code, whatever code I want to execute as a thread. So let me write here println, this is T1 thread, and at the end I will simply say dot start. Or if you want to write it on the next line, that is also possible, T1 dot start. Now this T1 thread will also execute. Let me complete this. Let me compile. Okay, sorry. Java C thri dot Java, and now Java thri. So I hopefully, yeah, here you can see that there is output. This is thread 1. Now you can have as many threads as you want in the same style. Let me copy this. Let me copy this entire code, and here instead of T1 I will say T2. Here also I will say T2 and thread 2, right? So now we will have 2 threads. So let me compile and run. Now here you can say that this is thread 1, this is thread 2, and now you can simply go on adding this code, and those many threads will be created, and each thread will be executing different code. Not each thread will not execute the same code now. So this is how you can add as many as run methods you want. Now, if I change my question, how many run methods you can have per class? If you can write this inside a main method, then you can write it inside anywhere, any other method, right? So you can also have as many run methods as you want per class. So this is the normal practice of writing a run method inside a class. But if you apply this practice, like creating a object of thread and directly passing a new runnable, then you can have as many run methods as you want in each class. So this is the good case. So I'm going to conduct a quick poll, and then we'll stop this lecture. So let me stop sharing. Okay. So then, okay, there is a question by Neil Doshi. Then why do we need to declare run outside of a main function? Okay, let me share the screen again. Sunil, I don't think you got the test. So thread, it is creating an autonomous object. This T1, let me create a plain object of thread1. So thread, let's say T10 is equal to new thread, right? And if I say T10 dot start, I have to write here T10 dot start. So what is going to start? The thread still, see, thread is getting created. Thread number is T10, but this thread has nothing to execute. So what this thread has to execute? This thread has to execute a code which is written inside a run method. Now this is the independent object created directly against the thread class. So how did this T10 gets a run method? So what we can do is we can pass an object of a class which is implementing a runnable interface. In our case, that is thri. So that is what we have done here. So we created an object of a thri and we are passing it to the independent object of a thread obj, and then we are saying t.start. So this t.start triggers the call to the run method, right? So what is the beauty of this run method? This run method have access to the all resources which are declared in this class thri. Right now I haven't declared any resource, but I thought that you will understand this because of this race condition class in which we were creating the resources, or this locking class in which our classes were having resources. So this all resources are accessible to this run method. If you declare a method inside a main, then that run method will not have access to these resources, right? So that is a limitation. So if you want to really have a code which is totally independent and you want to create a thread of this is the approach. If you want something which is requiring the help from the class, then this is the approach. Have I answered the question, Neil?
Yes, sir.
Yeah, great. So there is also a second question by Aditya. Is that re-entrant lock performs the thread serially as in main? No. Re-entrant lock also goes in parallel, right? So you can have as many re-entrant locks as you want, and those all re-entrant locks will execute. Right now, why this happened in our case in the serial order? I used only one lock. That was the question, right? So what is the drawback of using one re-entrant lock? So as I was using only one re-entrant lock, my program became serial. Even if my two threads were running at the same time, the program executed a kind of serial fashion. If I put two re-entrant locks, then my program will not run in serial order. It will run into the parallel execution. Have I answered your question, Aditya?
सर दॅट इज नॉट माय क्वेश्चन. मला असं विचारायचं होतं की आपण जर एकच थ्रेड क्लास डिफाईन केला आणि
हा
त्याच थ्रेड क्लासचे 4 ऑब्जेक्ट करून आपण ते रन केले मेन मध्ये,
हा
तर ते 0 पासूनच स्टार्ट होतात. म्हणजे काल तुम्ही टास्क दिलेले ना, तेव्हा
हा
मी परफॉर्म पण बघितलंय.
ओके.
तर त्यामध्ये 0 पासून सिरियली ते सर्च करायला सुरुवात करतात पासवर्ड.
हा ऍक्च्युली कसं आहे, हा म्हणजे तुझा कोड मध्ये तू म्हणतोस की 250च्या पुढे जात नाही आहे डायरेक्टली.
हा
नाही ते लॉजिकचा प्रॉब्लेम असा. यू कॅन डू दॅट. आय थिंक देर इज सम लॉजिकल मिस्टेक अँड यू हॅव टू फाइंड इट. अदरवाइज इन द लॅब ड्युरिंग द लॅब सेशन यू कॅन डेमॉन्स्ट्रेट द code and we will find where is the logical mistake. But it is possible that each thread will have its own counter. That is only a logical part.
ओके सर,
Okay.
थँक्यू.
Any other question? Okay. So here is the question on the poll. Everyone must attempt the poll. So question is coming. Let me type the question. Poll is open. Everyone please attempt the poll. So let's share the results. So here you can see that the actual correct answer, very correct answer is runnable, but many people have given the thread class. So thread class constructor do not really accept the object of thread. It accepts the object which is of type runnable. Those who have said your class may be the accepted thing because your class may inherit a runnable interface and then it will work it. And then some of the people are given all of this. This is also wrong answer, right? So keep in mind the thread class constructor accepts the object of type runnable interface. Okay, you can leave the meeting. We'll meet in another session.